Back in the days when we didn't have welding machines, if you wanted to attach two pieces to each other, you could use rivets, you could solder, or you could forge weld. And forge welding is what we are going to talk about today. I'm going to forge weld a ring. I am using a 6mm round bar that I'm going to close here. It will get hot. It's really hot outside here in Sweden. And when I forge weld, I do have to stand close to the forge all the time, because the temperature of the workpiece is critical when forge welding, so I need to determine, I use the color of the iron to determine the temperature, so I will need to stand close to it, so it will get hot. I prefer doing this in the winter, but what we need to forge weld. So what I'm going to do first is to create a scarf, and that is basically making a very short taper, I'm gonna do like this, and thinning out the very end, and I'm flipping it, doing the same at the other one. I will brush it off a little bit. And the reason I do these scarves is that if I wouldn't, and I would have these ends just straight as they are, when I forge weld and hit the material together, it would be a part of the bar that the very end wouldn't weld to the other, so it would just dig into the material, and that would cause to a crack. So therefore, when I have this taper, it will blend in the other material and be smooth and without cracks. So that is the first thing we need to do. The other things that is critical when it comes to forge welding is, as I mentioned, the heat. We want to get up to right below the melting temperature of iron. And another enemy that we are battling here is, oxygen. Oxygen in a way. Forge scales. Forge scales is that, you will see on this, when I'm forging here, it will come some scale. See these dark parts was falling. When I forge with children, they used to say, "Oh no, the iron is falling apart, it's destroyed, it's going." But that is simply when oxygen hits the hot iron, it reacts and makes an oxide, which a type of rust. And that scale will prevent the iron to stick to each other. So definitely something we don't want, because otherwise our weld won't take. And that is the reason flux is used to protect the material so oxygen doesn't come in contact with the iron. I am not going to use flux here because I don't need to, and the reason is I am only forging with mild steel here. Therefore I can bring up the temperature so the surface of the material is molten, and that molten iron will act as flux. So when I hit the piece, you will see sparks flying, and that is the molten material and also scales that it has brought with it. So I'm not going to use flux today, but anytime I'm forging with high carbon steel, it is necessary to use flux. I will take a break here. I am soon at the right temperature, so do some welding. Where are we? I need to... Oh. Don't have the... we are there. Oh, that didn't end up well. But we will do it again. I usually repeat this process maybe 3 times in general. But the reason we need flux when we are doing forge welding on high carbon steel is that we can't heat up high carbon steel to that high temperature as we can with just mild steel, because if we are melting the high carbon steel, we are ruining it. So therefore we need something else to act as flux. There we go, much better. Yeah, so anytime I forge tools with high carbon steel, I'm using flux. But otherwise I sometimes use anyway, but because it makes it easier, definitely. But I thought I would show that it is possible, you don't have to. And as flux, borax is probably the most common and it works well. I'm using borax. You can also buy some flux made for blacksmithing. You can also use a fine sand. So they are a little bit different. Different types of flux that can be used. I haven't done that much experimenting with it. I've tried a little, but I would have to do more research before I do my final decision. But I've heard that high carbon steel, if you mix, like when you're laminating a blade, you are forge welding mild steel and having high carbon steel in between. And that high carbon steel, I have heard that it will make the weld stronger. But my experience is I haven't noticed a huge difference. So I don't know if it is true. But one thing that I tried was to mix borax with high carbon steel powder and use that. So But who knows? If you want to try, I'm happy to hear the results. It is a good recipe. So now I'm just shaping it. I am happy with the weld now. I'm just going to shape it into noticed that I didn't spend too much time at the anvil while I was welding, because there's no reason to tap the iron while it's not on the right temperature. So I prefer to, even though I have to go back and forth maybe 1 or 2 times extra, I prefer to take a couple of hits, and then while the iron is still hot, I put it in the fire, so I don't have to heat it up as long again, and taking shorter sessions at the anvil, but doing it a few times extra. That's what works best for me. But yeah, there we have our ring welded. This is 6mm round bar. If you're there are pros and cons with going with thin material. I would say 6mm is relatively thin, but I used to forge weld 4mm as well. But it is difficult because it cools down very quickly, so you have to be fast. But on the other hand, it is easy to heat up. So yeah, pros and cons. But I would maybe recommend 10mm is a good starting dimension. Then you get it is easy to heat up, and still gives you some time to forge weld. So I have made these rings before, and I'm gonna do one more weld. Now I'm gonna attach it all together. I need to cool down so I can hold these. One way to, if you want to work with thin material, one way to make it easier is to, as you can see, I have a anvil close to my forge here, and that is what I use when I'm forge welding thin material, because then I'm very fast working on the anvil, so I can put it easily back in fire. So that is a good way to work with thinner material. Alright, so what I'm gonna do now is I'm gonna attach these like this. Then I'm gonna close this in the same way. So I will have to, we'll see if I should tie this together or what's easier, but I will first make the scarf and bend the end into the right shape. When forge welding also, it's very light taps and fast, because it is possible to forge weld at lower temperature than we are doing here, but then we will need more time and more pressure. And with modern tool, it is possible with a press. But with a hammer, we can't really have a pressure for a long time. So therefore we need to have a high temperature. And in order to get the material forged to each other as long as possible, then you tap very quickly. So when I weld this thin material, I used to change to a lighter hammer just so I can hit a bit more quicker. Like this, I bent it a little bit too much, so I will open it up like so. And then before I close it, good to put everything on, because otherwise it will be difficult. So I got it like this, and then I will see, maybe I can hold it like this. But again, it will get very hot because I will have my hands close to the fire. This is when you are forging chains as well, you will have some hanging pieces which can be in the way, so to speak, but we will see. We'll do our best. Like this. I might want to use Flux now, because as you can see, the ends here they are a bit twisted. So I will put some Flux on here now, because I need to heat it up one time extra before I weld it. And there is a risk too that it is building scales here. And once it is scales, it just takes a tiny part and it will make it very difficult to get a good weld, and it's difficult to repair. So therefore I'm gonna go with some Flux. The way I'm determining the temperature, as I mentioned, it has to be right below the melting temperature. If you're looking at forge welding, you have probably heard that you can watch when it's throwing sparks, then you are at the right temperature, and that is well, it is somewhat correct, but it's not really good, but because when it is throwing sparks, first it doesn't tell you if the material is heated all the way through. It is most likely a thin part that is melting and throwing those sparks. And second, when you are at that temperature, you are actually too high. But when forging mild steel, it doesn't it's no bigger harm. But what I used to do is to, when you look in the middle of the fire here, you will see that the fire is very bright. It goes from red to orange to white. And when my material is the same color as the white fire, then I know I'm at the right. We'll also see that it looks wet in a way. Now I am at the temperature and there is no sparks yet, but I can wait a little bit and see. Yeah, there we have some sparks throwing, and now I can, like this. So the first heat, I always just tap it and tack weld it. So now these two pieces are joined. I should do something about those rings. I will get a wire and tie it together. So in general, on the first heat you tack weld it so they stick together. On the second weld you do the actual welding or making it a strong weld. And you will probably need to shape the material, especially if you're forging a ring like this. You want to make the scarf round in cross section as well. So you will probably need to shape it a little. Therefore you take a third heat, and just to make sure the weld doesn't open up again, you go at welding temperature. And I sometimes do four times. So it depends a bit how it goes. We'll see. Well, now I think it's okay. I will try like this. It's gonna get hot and I will need to wet my hand a little bit. Otherwise it will hurt. So I'm waiting so I get the material hot enough. And all the way through. Didn't have the optimal fire here. We'll see. I should also have the other hammer. Lesson learned. Prepare. Be prepared. You don't have much time when you are at the end of. But there we go. I can now change hammer. And from now these are welded, but I want the cross section to be round. So therefore I'm gonna take a couple of more and forge over the form. I will at least go once at welding temperature. There is of course always a risk when bringing that temperature up that high. There's a potential to burn the material, so not necessary. Then don't go to that temperature. Let's take a look. I will do some more shaping. Oops, oh, that was close. Now I'm just shaping it. Here. Just gonna make this straight, and out there we had a little bend. Like that. And that looks good. That looks good. Perfect. And that's how I used to do forge welding. Do we have a... I'll take this one and release these rings. Like so. Perfect. So a quick summary. When doing forge welding, temperature is critical, right below melting point. And instead of judging color or the temperature by looking at sparks, I recommend to look at the color of the fire instead. And once the material blend into the same color, then you know it's right. And you will, once your eye gets used to it, you will be able to see that the material looks wet in a way. It's starting to glow in a special way, so you will notice that. And second thing is forge scales is a problem, and there are a couple of ways to reduce the amount of forge scale, and that is when you're forging in the fire, you can make a larger fire than you normally do, because then you can have your working piece a little bit higher up if you have a force that is blowing air from the bottom. That will make a more even heat, it will make a hotter heat, and also less oxygen here, so more pure. And use flux, that helps. And yeah, quick summary and view how I do it. Hope that was helpful.